Good morning. I'm Elizabeth Broadbent from the University of Auckland in New Zealand, and on the screen here you can see my colleague, Professor Bruce McDonald, and together we've been doing quite a lot of research in healthcare robots. So some with Paro, some with iRobi here. iRobi is a Korean robot, and we've been using them autonomously in people's houses and in retirement villages. And so I work with the Centre for Automation Research and Engineering Science, and we're a multidisciplinary group of engineers, computer scientists, healthcare professionals, pharmacists and psychologists. And particularly for this talk, I'd like to acknowledge Dr. Ho Suk An and Debbie Johansson, who's a PhD student who's been doing a lot of this work. So I'm going to talk a little bit about some of our recent work in healthcare robotics, and then I want to talk about what perceived safety might mean for robots in healthcare. And I'll present a model that we have designed to try and increase engagement and increase perceived safety with robots in healthcare, and then talk about a couple of studies that we've done to test that model and move on to conclusions. So this is one of the most recent studies that we've been doing, and it's a little video that I will play.
This project is a collaboration with South Korea and with IFA Women's University.
There was a common interest to see whether robots could help older people with mild cognitive impairment.
Here we have two different robots here. The first robot here is an interactive game robot. It will keep the patient mentally alert by offering a different range of the games. And this robot is a daily care service robot. All these robots are connected to the medical server. All analytic data can be used remotely.
So the daily care robot has been designed to be used in the homes of older adults, and it provides reminders for their daily routines. So the reminders include bedtime reminders, waking up, as well as medication reminders, going out, and playing the 6 cognitive games that the games robot delivers. In this qualitative feasibility study, we recruited 6 older adults with normal cognition or mild cognitive impairment, and we explored their use, perceptions, and experience of using the robot.
So the games robot has got a number of different games on it. So one is a dressing game where you have to remember what clothes the person is going to wear that day. Another one is a cooking game where you have to remember what to cook for dinner and how to cook it. The aim of playing the games is to try and improve cognitive function.
Like most people who are over 60, you do start losing your memory. You can't recall things quite as quickly. But I did notice the other day, I do a lot of solitaire patients on my laptop, and I noticed in the last 2 weeks or so that my scores are higher. So I thought, well, I wonder if that's that, but I guess it must be because it was consistent.
The participants who have interacted with our robots have been really helpful. They've given us a lot of feedback initially about what to improve on the robot. It's an absolutely key part of what we do. A lot of work we do is co-designing robots with the people who are going to use them.
Overall, the residents were really accepting about having the robot in their homes, and they particularly liked and valued the medication reminders, things like taking pills, performing blood pressure checks at home, as well as going out to visit their GP or attend a physio appointment.
I think that with the ageing population and with the advances in technology we're going to see in the coming years, that robots are going to be very useful for improving people's health.
My makers would like to acknowledge everyone involved in the 5-year study. Thanks also to the Selwyn Foundation and Somerset.
And some other work that we have been doing a few years ago, this is a meal delivery robot that we had operating in a retirement facility, and it would the staff would put the meals into the robot, and then the robot would move from the kitchen along the corridor to where people ate, so in the dining room. And then some other staff in the dining room would unload the robot, and then people would eat, and then the dirty dish would be loaded back into the robot and move back along the corridor. Another project that we were doing, this one was at a laboratory testing facility, so pathology, and so the robot would, you can open it up and it's got drawers inside, and so blood specimens and urine specimens and things can be loaded inside, and then the robot would move to where the laboratory technicians were, so then they could, the robot doors would open and they could take out the samples for testing. So that's another couple of projects that we have been involved in recently. And I guess what we have observed over the years that we've been doing such studies is that in healthcare, safety is about feeling safe and comfortable in a particular situation, and it's related to feeling like there's a low risk of harm occurring. And in healthcare, you're not only talking about physical harm, so we've had people concerned about the robot bumping into people and causing skin tears, because older people have thin skin, possibly, yeah, running into people, possibly people tripping over the robot if it's in the corridor, or older people trying to use the robot for balance, but then the robot falling over. That hasn't happened, but that's what people have been concerned about. But also, you have to be worried about what kind of advice the robot is giving to people. People have expressed concern that maybe the robot isn't giving them the right advice, maybe about their condition. You also have to worry about the robot not keeping people's information safe, breaches of privacy, for example, if it's got a video on it. And also some people were worried that if something was wrong, the robot wouldn't actually tell other people that there was an emergency. So these are some of the concerns that people have about safety. And people need to trust robots in order to share personal information, and then trust that the diagnosis is right, trust that the advice is right, and feel safe using them. And so this, we think, is similar to how you must feel when you are interacting with a physician or a human doctor. And so a few years ago, we tried to think, what are the components that go into making you feel safe with a physician or a doctor? And so there are models about patient-doctor communication, and we have built a model on robot-patient communication. So in this model, you've got the background variables of the patient, so how old they are, what gender they are, their culture, education, etc., and the same kind of variables for the robot, what it looks like, what kind of voice it's got, its personality. And then you've got the communication factors, so this includes verbal and non-verbal communication, affective and instrumental, which is like emotional and informational communication. You've got shared decision making rather than just the doctor making the decision for you. Keeping information confidential, and then this social rules for appropriate medical behaviour. So this is things like, you know, when you go to a doctor, then you get undressed behind a curtain and the doctor doesn't watch you get undressed. So the robot has to obey these same rules. And then these factors, the communication and background variables, they influence patient outcomes like satisfaction, understanding, engagement, adherence, and their health outcomes. So we've transformed this model into a robot patient communication model. And then we've gone about testing it to see if it does make a difference to how safe and comfortable people feel. So we have done a few different studies in this area. And the first study was on using the non-verbal behaviour of smiling and the verbal behaviour of using a patient's first name. So this study was published in the Paladin Journal of Behavioural Robotics, and this was the robot we used. It's called Ever 4. It's a Korean robot. It does come with a body, but we could only afford the head, so we've only got the head. So we had 4 interact with this Ever 4 robot made by Keist, and it was a Within Subjects Wizard of Oz design. And they had a 2.5-minute scripted interaction with this robot medical receptionist, and they did it 4 times in total. And these 4 conditions were in a random order. So in the neutral condition, the robot didn't smile and it didn't use the participant's first name. In another condition, it smiled but didn't use the person's name. Another condition, it used their name but didn't smile. And in the final condition, it both smiled and used the person's name. And in the script, people had to come along and say they had a doctor's appointment. The doctor wasn't ready, so the robot said they had to wait. Then they had to pay for the doctor's appointment, schedule another appointment, and then go to the pharmacy. So what we found in this study was that smiling made a big difference and use of first name did not make a big difference. So in conditions where the robot smiled, the robot was rated friendlier than in conditions where it didn't smile, and use of name made no difference. Similarly, with mind perception, when the robot smiled, people thought the robot had greater agency and also that it was capable of feeling more emotions, and use of name made no difference. We also looked at attitudes. So again, smiling resulted in better attitudes towards the robot and thought that the robot was more human-like, but the use of name made no difference. Personality, smiling resulted in people thinking the robot was more generous and happy, good-natured and warm, sociable and humane. And in this personality outcome, use of name was associated with perceiving the robot as more humane. And then in terms of the user's own behaviour, when the robot smiled, this resulted in participants smiling more often as well, but the use of name had no effects on smiling. So that just shows that the robot smiling had quite large effects on people's interactions with the robot, their ratings of the robot. And the majority of people thought that Eve would be a good addition to a doctor's practice and be good in a busy clinic and be a bit like a supermarket self-checkout, but there'd still be a need for human supervision because they thought she might not be able to handle complex tasks or problems. The next study was on the use of attentional behaviours. So this is because attracting attention, maintaining attention, and showing attention are all fundamental aspects of human communication. And this study was published in the Journal of Medical Internet Research. So we looked at 3 things. We looked at self-disclosure. Self-disclosure has been shown to increase mutual eye gaze, smiling, and ratings of perceived friendliness and rapport in human-to-human relationships. And developing more social closeness. So this is self-disclosure is when you reveal something personal about yourself. And in terms of robotic studies, self-disclosure has been shown to reduce anxiety and increase likability of robots, but little has been done in the healthcare domain. We also looked at voice pitch. So voice pitch is important in attracting attention. It can sustain attention if it's a good voice pitch, and it can convey emotion as well. And there's been one study looking at voice pitch showing that higher robot voice pitch increased robot likability, attractiveness, personality ratings, and more enjoyable interactions. So we looked at those factors, we also looked at forward lean. And this is because in physician interactions, forward leaning demonstrates attention and listening. And it's been associated with positive perceptions of physician empathy, but there's been no studies with robots. So in this study, we were looking at forward lean and voice pitch changes increased attentional behaviors and perceptions of the robot's empathy. So we had 181 participants. They did a 5-minute scripted interaction with Now. And it was similar to last time. They had to pick up a prescription, make a doctor's appointment. They had to wait for the prescription, and then they had to ask where the bathroom was. So participants were randomized to one of 4 conditions. Either the robot revealed a little bit about itself in the self-disclosure condition. It said, I'm a little nervous about this task, or I forget things too sometimes. There was a voice pitch condition where it said some things in a high-pitched voice and some things in a low-pitched voice. There was a forward lean condition where the robot leaned forward when it was speaking, and otherwise it was upright. And then there was a neutral condition where it didn't lean, didn't use self-disclosure, and it kept a constant voice pitch. And the results of this study showed that when the robot was leaning forward, participants rated the robot as more stimulating and interesting. They spent more time looking at the robot, and more participants leaned towards the robot themselves in response to the robot than in the other conditions. So we think that the increased eye gaze means that this increased participant engagement, and the leaning might either be a form of mirroring the behavior, or it might indicate higher engagement. With the self-disclosure, again, people rated the robot more stimulating and interesting. They spent more time looking at the robot, and more participants laughed during the interaction compared to the other conditions. So again, with the eye gaze, we think this suggests participants were more engaged. With the laughing, we weren't sure if that was due to the self-disclosure in itself, or because they thought that the things that we had made the robot say were funny. In terms of the voice pitch, there were no significant effects of voice pitch compared to the other conditions, and if there were even some slightly negative effects. And this might be because we had the voice going up and down rather than just up. And we've also recently conducted a study which is in press in the journal Mind, Technology and Behaviour. And in this study, we had that same Evo robot either in a medical situation say something humorous or not humorous in the middle of the conversation. And we found that this humour increased people's perceptions of likability of the robot and how safe it was in healthcare. So in conclusion, we can increase user perceptions of the robot's safety, likability, and friendliness, and engagement by using these verbal and non-verbal physician communication skills, including smiling, leaning forward, self-disclosure, and humour. And this supports our model of robot-patient communication, but we can't just increase people's perceptions of safety if it doesn't match objective safety. So we don't want to breach people's trust. So when you're making robots, you need to be very open and honest about the robot capabilities and how secure everything is. And I will finish there.
Okay, thank you very much, Professor Broadbent. It was very interesting talk. We have a few set of questions. What would you like to make the question? Okay, so the first question is, was the sense of trust also looked at, I guess, in the first part of the studies?
Sense of trust. I think we looked at trust in one of the studies. I can't remember exactly.
Okay, so let's go to the next question. So did you conduct a study comparing the reactions to a human-like talking head versus the robot-like one?
We have not done that directly, no. We might do that in our next study.
Okay, that looks interesting, yeah. Itself, a robot head, it looks very funny. It looks...
Yeah, we do get a few comments, but most people are pretty accepting.
Yeah, okay.
Really, we put a nice scar.
Okay. So another question we have is, how do you think that familiarity with the robot can affect the perceived safety?
I think, you know, if you have interacted with her before and it went well, then that would increase perceived safety. If you interacted with her before and it went badly, then that would reduce perceived safety.
That's probably, yes. Did you have some like studies that show like patients that come constantly, they kind of feel it more safe around the same robots, or first-time users will be more afraid of it? Did you get any this kind of?
We have showed that in some of our studies, people were afraid of the robots, but then after they had the opportunity to interact with the robots, then they felt better actually, because they could see that the robots were not as, I guess, scary as they initially thought.
Okay.
But we have had some, you know, sometimes we've had a robot in a rest home and people have, only some people interact with it, some people don't.
Okay, so we have one more question. Says, when you talk about the voice pitch condition, was it that you stuck the particular pitch voice for specific sentences, or did you use the pitch to emphasize specific words or indicate questions?
Yes, we used it for specific sentences. I'm sorry, your prescription is not ready yet. We said that in a low voice because it was for a reason. It was because sort of like apologizing. And then when they were sort of trying to exclaim, sort of exclamation mark, sort of no problem, or have a nice day, that was kind of in a high pitched voice, sort of, yeah, an exclamation mark.
Okay, I see. So one more question we have is, how can you evaluate the safety? For example, in the scenarios when a robot is moving among patients, which factors are more important and which are less?
Yeah, I mean, I think the movement thing is tricky. We most of the time in our studies have the robot stationary, but obviously when we had the robot delivering meals and delivering the pathology samples, then it was moving. And we asked all sorts of questions about the speed of the robot, the lights on the robot, the sounds that the robot made, and they were all important. Most of the time we had the robot going fairly slowly, and there was a little bit of sort of, I guess, particularly in the pathology lab, there's sort of like a need to get samples to their endpoint fairly quickly, and yet you don't want the robot to go too fast because you don't want it to bump into people. But, you know, it's two different places. One is a rest home where you've got old people who are less mobile, who might have walkers and things, and they leave them in the corridor, which makes it tricky. Whereas in the laboratory testing facility, you know, you've got younger people who are much more mobile and able to avoid the robot by themselves.
So related to that, what was the feedback from the people running the facilities? Like, do they trust the robot to do this kind of activities? What kind of activities do they expect these robots to do? What do you get from them?
Yeah, I mean, I think both of the facilities were fairly positive about the robot, but say in the lab test facility, there were some comments that they needed the robot to be a bit bigger so that it fit more samples in it, and that it needed to go a little bit faster. And in the retirement village, they were pretty happy with it. Most of the residents were feeling pretty safe about the speed, although there was one resident who was a little bit scared of it.
Okay. quite a nice feedback then. A lot of work to do then.
Yeah.
So we thank you very much for your talk. It was quite interesting and nice to see all your work. Now we move to our next short talk, which